Today we will be starting our fourth unit, which is on graphing trig functions. Our first lesson is just learning how to graph our three main trig functions, sine, cosine, and tangent. So let's start off with sine. In our calculator, we first want to make sure we are in radian mode. So go to mode, make sure you're in radians. Now we're going to go to our y equals and enter sine of x. Our window is going to be set using the following numbers on your paper. So we're going to go to window and type in, we want x min to be negative 2 pi, x max to be 2 pi. It's okay after you type it in and you go down, the 2 pi will turn into a number, that's fine. Our x scale, we want it to be pi over 2, so those are our tick marks. Y minimum is negative 2, y maximum is positive 2, and our y scale is 1. So once you have all of these in your window, we're going to press graph. And this is what the graph of the sine function looks like. So we're going to plot all of these points on the graph on your paper. So the easiest point to start off with is 0, 0, the origin. Our sine graph starts at 0, 0. Each of these tick marks we know is pi over 2 on our x-axis. So at pi over 2, the point is pi over 2, comma, here's 1. So that's going to be the second point that we plot. Pi over 2, 1. If this is half a pi, pi over 2, then this must be a whole pi. So at pi, again, it hits 0. And at 3 pi over 2, now we're down to negative 1. And once we get to 2 pi, the very edge of the graph, we're back to 0. So we're going to connect these using a smooth curve. In case you are curious, the point pi over 6 is going to give us 1/2 because sine of pi over 6 is 1/2. We know that from the chart we memorized. So if you wanted to be very exact, you could plot a point there as well, but it's not necessary. So we're just going to draw our smooth curve through those points. And same thing on this side. So now at negative pi over 2, it's at negative 1. Negative pi is 0. Negative 3 pi over 2 is at positive 1, and negative 2 pi is at 0. So again, we're going to connect this in a smooth curve, and this is our sine function. The next thing we're going to do is change our window to an x minimum of negative 4 pi and an x maximum of 4 pi. So back to window. Our x minimum is negative 4 pi. X maximum is also 4 pi. And so when we graph this, what we're really trying to do is see what happens when we zoom out, what's happening in the rest of your graph. So when I press graph, now we've seen a little bit more what's on the left and on the right, and as you notice, it's the same thing. All right, what does the graph look like when you move beyond 2 pi? The pattern just repeats itself. If the same pattern is repeating itself over and over and over again, that means that this is a periodic function. And one period is the part of the graph that keeps on repeating. So if we look at the unique part of the graph that keeps on repeating, it's really just this section from 0 to 2 pi. Right? So it goes up like a hill and then down like a valley. This is the part that keeps on repeating over and over and over again if we extend the graph. So because of that, we say that our graph here has a period of 2 pi. Because that's the length that keeps on repeating itself over and over again. So now back to some algebra vocabulary. The domain here, which are all your possible x values, because it keeps on going forever, right, beyond this graph it keeps on going, your domain is from negative infinity to infinity because it covers all possible x values. Our range, however, our lowest y value it ever reaches is negative 1. And it includes negative 1, so we're going to use a bracket. And then the highest y value this graph ever reaches is positive 1. So our range is from negative 1 to positive 1. Both brackets because the point is included, it's a closed circle. So now let's look at our x-intercepts. X-intercepts are where it crosses the x-axis. So we have 1, 2, 3, 4, 5 right here. This first one is at negative 2 pi, comma 0. Then we have negative pi, comma 0. 0, 0, positive pi 0, and 2 pi 0. So these are all the places where your graph crosses the x-axis. The y-intercept is where it crosses the y-axis, and that is at just one point right here, 0, 0. Okay, so this is our sine function. Now we're going to go back and do the exact same thing for cosine. So on the next section of this page, we're going to go back to our calculator, press y equals, clear, and enter cosine. Go back to our window. We want to change the window back to negative 2 pi and 2 pi for your x minimum and x maximum. And so when I press graph, your graph should look a little something like this. Alright, so this time your y-intercept is at 1. 1 is the starting point. When it hits pi over 2, we're now at 0. At pi, it's at negative 1. It hits 0 again at 3 pi over 2 and goes back up to 1 at 2 pi. So in this case, our graph looks like this, and same thing on this side. So notice for all of our tick marks down here, one space is pi over 6 units. This is the same as what we just did for the sine. So this is pi over 6. If we added another one, it would be 2 pi over 6, which is the same thing as pi over 3. Right? If we add another pi over 6, this would be 3 pi over 6, which is pi over 2. So that's where we're getting all these numbers from. This is going to become more important to us later on this unit. We really don't use it much today, though. So again, this is also a periodic function because it does keep on repeating itself. The section that it's repeating this time is this one right here. Again, it's from 0 to 2 pi, so the period is still 2 pi. And it's going to repeat this shape over and over and over again. So the domain still repeats itself forever. So we're going from negative infinity to infinity. Our range, lowest y value is still negative 1. Highest y value is positive 1. So it's from negative 1 to 1. Brackets, because this point is included. Our x-intercepts, so these are a little bit different. This time we only have 1, 2, 3, 4. And we have negative 3 pi over 2, 0. 0 is our y value, which is just a 0. We have negative pi over 2, 0. Pi over 2, 0. And then 3 pi over 2, 0. And our y-intercept here is up here, which is at 0, 1. So both sine and cosine, they look very, very similar. Cosine is just moved a little bit to the left of sine, right? So they look very, very similar. The graph of these two functions are called sinusoidal functions. So I know it's kind of a strange word, but if you ever hear it, sinusoidal, it's referring to either the sine or the cosine function. So the biggest thing that you guys are going to need to remember is the difference between sine and cosine. Right, so we just got both of them. The thing to remember with sine is that the sine graph always starts at 0. That's its y-intercept. And the period looks like this. It's a hill and then it's a valley. That's one period. The cosine graph starts at 1. And its period looks like it starts up here at the 1. So it's kind of like this. Where it starts at the top, goes back down, goes back to the top. So this is going to be the key thing to remember here when you're graphing sine and cosine. Sine starts at 0, goes uphill, valley. Cosine starts at 1. It starts at the top of the hill, goes all the way down, and ends back at the top of the hill. Okay, so we're going to graph one more, which is our tangent function. So on our calculator, we're going to again go to y equals, and clear this, type in tangent of x. We're going to go to our window, and this time we're changing the y minimum and y maximum, so be careful you're going down to y. So here's y minimum. It used to be negative 2, we're going to make it negative 4. We're going to make our y max positive 4. Press graph. So this one obviously looks a little bit different than our sine and cosine. The reason being, if you remember when we do tangent, a lot of times we actually get a number that is undefined. When you have a number that's undefined, it's going to give us something called a vertical asymptote, which is a line that your graph approaches but never actually touches. So let's first start off by drawing our vertical asymptotes. The asymptotes are what is happening right here, right here, right here, and right here. So it's at negative 3 pi over 2. I'm going to draw a dashed line as my asymptote. Negative pi over 2. Positive pi over 2. And positive 3 pi over 2. So those are my vertical asymptotes. I'm going to start here 0, 0. And as you can see, on one side it curves up, on the other side it curves down. Just so you know, pi over 4 is where it's going to hit the 1 mark. So pi over 4 is halfway in between pi over 6 and pi over 3. So it's going to hit 1 and then go up towards your asymptote. Again, this is kind of just like halfway in between the vertical asymptote and the center. This one goes down towards your asymptote. So each of my sections is going to look just like this one because it repeats itself. Just like sine and cosine, this is a periodic function, and it's just going to repeat the same pattern. So this one, the center of this one is at pi. Again, halfway in between is where it touches 1, and it's going to go up towards this asymptote. Halfway in between it touches negative 1, it's going to go down towards this one. Over here, 2 pi is the center. I'm not going to draw the left side because it goes off the graph, so I'm just going to draw that's the right side. The left side is going to just go down. So again, it's the same thing repeating itself. Again, negative pi is the center. Halfway in between is right here. It's going to go up towards this asymptote and then go down towards this one. Then we have negative 2 pi, which for this one we're only going to draw the right half of it, which is the part that's going up. So for this one, our period is just this one section, which is what's in between negative pi and pi over 2. And this section is actually only a length of pi. Right, because between negative pi over 2 and pi, this thing is a length of pi. So unlike our other two, this one has a period of just pi rather than 2 pi. So our vertical asymptotes, the 4 that we drew, 1, 2, 3, 4, we're not going to write these down. We have x is equal to negative 3 pi over 2. That's this first one. X is equal to negative pi over 2. X is equal to pi over 2. And then x is equal to 3 pi over 2. So those are our vertical asymptotes, these dotted lines. So our domain this time is different because it does not include all of the x values. The vertical asymptotes, because they're points that it never actually touches, those are not included. So your domain is all real numbers except for all of the vertical asymptotes. So x cannot be equal to, so equal with a slash to it, cannot be equal to any of these, which we know are going to go on and on and on forever. But if you notice, so this is negative pi over 2, 3 pi over 2, the next one's going to be 5 pi over 2, the next one's going to be 7 pi over 2. So the domain cannot include all the odd multiples of pi over 2. Because this keeps on going forever. 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, but it's only the odd ones. Our range, if we look at going on our y-axis now, up and down, because it keeps on going forever, your range goes from negative infinity to positive infinity. Okay. Our x-intercepts. So we have this one right here, 2, 3, 4, 5. So let's write these down. We have negative 2 pi 0, negative pi 0, 0, 0, pi 0, and 2 pi 0. And then our y-intercept, where it crosses our y-axis, is just at 0, 0. So these three graphs you are going to need to have memorized. We're going to practice it a bunch today, but this is important because tomorrow we're going to start transforming our graphs. So shifting them, stretching them, so on and so on. The same thing we've been doing to other parent functions.